Okay. First, I don't know why someone told me to come here, because actually for me, usually we talk about glass, we talk about design, we talk about innovation, we never talk about what is being told here. So I said, why are you calling us? That's what we do. I only talk about glass, about innovation, about 3D glass, innovation and design, and they said, that's why we call you. So maybe I have something to say. But to tell you the truth, we are not used to talk about this, all right? And here what we see is a lot of people that know a lot about what I have to talk. So if people around here are at level 9 or level 10, I would say I'm at level 2. But outside of these walls, I would say everyone is at level 0. And that's what's important. So that's my topic. All these people around, behind these walls that are at level 0 have to be at least today at level 2, not even at level 1. So first, I'll do a little introduction. I already told you what we do. And then, so we are a very old company, 90 years old. So very traditional. We do glass. These are the glasses we were doing in the 50s. But we were also doing, here, if you came through the fountains in Montjuic, we did the glasses of the fountains in 1929. This is what we were doing 20 years ago. We were doing compound shapes. We were doing the first spheres made of glass. But this is a very old thing, 20 years ago. 15 years ago, we were doing more complex glass, the first curved glass that you could put on a flat building, because we needed more business. So we thought, OK, we can put curved glass on flat buildings. This is around 8 years ago. We were doing very strange glass, 3D forms, so curved in one sense and then curved in another. So the shape is something that has always been attracting us. This is a hospital in Madrid. Or lately, a project in north of London. This is a distillery and very complex shapes made of glass. Or 600 molds that we had to do to make 800 glasses for a project in Malmö, in Sweden. And this is what makes you crazy. When you look at a project like this and you think, wow, we have to do 5 molds every day during half a year, this is too much work. And then you start thinking, OK, we have to find other ways of doing this in a different way. No time for this project, so we did the 600 molds. But we opened our ears to what was around there in the market to find other ways to be able to do this, because someone said, we need the client. No, the client is already there. We need to do what the client wants. Because if you can do it, the client is there ready to pay for it. These delayed things that we are, large scale is important. We are doing 10-meter glass. This is a project for a software appliance company that has an apple as a logo. And so this is for you to understand what we do. But you can understand we don't print these glasses. We manufacture them. So to do this, we did our first steps in advanced manufacturing. We didn't know we were doing this, but we were just doing it, like CNC cutting, developing, unfolding surfaces to cut the glass when it's flat. We cut and polish the glass when it's flat, so we have to unfold everything we have to do later. We were doing molds. I'm not going to show you because this is our core business, how we do molds. But we started implementing technology in doing molds. And like what I can tell you, we laser cut. This is very easy. We laser cut metal sheets to do molds. But one thing which is a little bit more important is, for example, for that project that you saw of 800 molds, we built 800 glasses before the first one was installed. And they all had to match together, one with the other. So there was no option for a mistake. If we did a little mistake, we would have 800 glasses in our factory not being able to be installed. So what we did is we developed a system to check every single mold, every single glass in an easy way. So we were scanning in 3D. That was a big thing. We are scanning now in 3D all our molds before we're producing the glass. We developed a program to check. That's a mistake. So see those two red lights? Very simple. In I don't know, it was Excel, I imagine. So we were connecting that machine to an Excel, to a computer, and then it showed that we had to modify the mold in 2 points in order to have a good mold without red points. And then we did a lot of other things like glass engineering. So geometry study, this is not very important, but there are not many glass companies that do this geometry study. So we use a lot of 3D software, and we develop a lot of 3D projects. Or we use finite element software to analyze stress. Our glass is in buildings. It has to be safe. So we have to work a lot in engineering. So the design has a lot of engineering. And also we have to transport. So we have to, when you are producing very strange things, you have to find ways to transport those things. And we have not yet found an easy way to manufacture these things, but in the future we think we will need. So this is probably what everyone here came to see. We don't know why, but we bought a 3D printer. So that's why we are here, only because we bought it. We did not know what we were going to use it for. We thought, okay, we will impress our clients with models. We did models like this one, or like this one. When an architect wants something, well, today architects, they already print what they design. But we started printing projects for our clients. Some of them very sophisticated, some others not so sophisticated, like this little piece that went to Venice for an art biennale. This was the first step. Then we said, okay, we can tell our people in the factory what they will produce. So let's print the glass that they will end up doing, like this one, all right? So if you tell someone what you need, they will imagine and they will make a better mold, probably. So this was the first approach. Very simple approach. But the printer was there. And suddenly, you find ways of using it, if you have it. For example, quality control. We take a lot of time checking, controlling things. Things have to be where they have to be, for example. And if you have people working at the factory checking if the printed line is in the distance it needs to be, it's very difficult. But if you print a very easy tool, it's very simple. They just put the tool, they check it, okay, it's good. Wow, we've saved a lot of time. Or to apply silicone at the edge of a glass, for example. We make a very easy tool, like this one. So someone is applying silicone and comes with this, very simple, and then it gets perfect. This is what makes you different from your competitors. A different one, placing things. So we don't do fancy stuff. This is what clients don't see. They see our glass, and it looks the best. It's much better than our competitors. And only because we do, every day we are printing 8 or 10 of these things. And it's people at the technical office. We have 6 people at the technical office that were the ones developing all the files for the glass. And now they make the files for the glass, and they make the tools that people will need in order to be able to manufacture what they have to manufacture. And it makes things very easy, extremely easy. To tell you the truth, I don't know what this is. But it's a tool that you can use to cut, place it here. You can make it at 5 centimeters, 6, 7, 8, 9. I don't know. I just stole it this morning from the factory. Someone is going to miss it. But this is what makes things really easy when you're manufacturing. And this is what everyone outside of these walls can do. And they don't know they can do. All they have to do is buy a machine. These are very simple elements, extremely simple. But they save a lot of money to everyone, to every company that is producing something. So now we are using for everything. We are, apart from doing glass, we make our machinery and we make our molds. So we make a lot of things in-house. So we need tools that help us make things. All right? For example, this. We had a client that had a big problem. And we sent glasses to Doha, and our client didn't tell us. So these glasses in Doha went through a process of high temperature, which meant that this is a very simple glass with air inside. When this glass gets very hot, the pressure inside of the cavity gets very high, so the air escapes, and then when it cools down, you have a deflection. So we needed to drill a little hole in this glass. And he said, okay, can you help us? Because we have a problem with your glasses, we need to fix them. And we said, okay, how are we going to fix them? All right, very easy. We need to drill a hole, but the hole has to have be in the precise place with a perfect distance. So only by making a very little tool that you go there with your machine, the most simple person can go there and do this job and then solve a big problem. Future challenges. As I told you, we are in level 0. We are not doing everything, but we think that with this technology, if we are at level 0 today, we will be in level 3 tomorrow. We need to be in level 3. So what can we use these technologies for? To do equipment, yes, I think we should do equipment. That's why I'm very interested in these printers that are using metal. We use a lot of iron, a lot of Inconel. Molds, we could use molds. For sure we could use molds. And maybe we could print glass. Someone is investigating in printing glass. So printing glass, why not? Okay, so basically what I would like to do is encourage everyone who's at level 0 to be at least at level 2, because everyone can be at level 2. Thank you.